Exercise 9.1, question 9, deals with the question of a swimming pool. The volume of a child's circular swimming pool with a depth of 3 over pi depends on the radius of the pool. The volume of the pool is given by V equals pi r squared h, where V is the volume in cubic metres, r is the radius in metres, and h is the height in metres. At this point, it is important to say that height and depth are the same thing. So the question part A says, show that the volume is 3 pi r squared. To show this, we are going to substitute our depth into our original equation, V equals pi r squared h. So we have V equals pi times r squared times 3 over pi. What happens here is that we have pi on the top line and pi on the bottom line. So we can say that that is pi over 1. Those pi's cancel each other out, and V equals 3r squared. When multiplying fractions, if there is a denominator in one of the fractions, it becomes the denominator for the whole fraction, just as written in yellow. 3 squared is... Part B says, explain why the relationship is quadratic. It is quadratic because the highest power of the variable is a 2. When V equals 3r squared, that power of 2 is the highest power, which makes it quadratic. Quadratics have a power of 2 only. In part C, we're asked to complete this table. Well, we use the formula V equals 3 times r squared to complete it. 0 squared is 0, 1 squared is 1, 2 squared is 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So since the volume is equal to 3 lots of r squared, then V is 3 lots of 0, which is 0, 3 1s are 3, 3 4s are 12, 3 9s are 27, 3 times 16 is 48, and 3 times 25 is 75. So we have found the volume if the radius changes of our pool from 0 to 5. Part D asks us to plot a graph of the relationship. On graph paper would be much better, and we know that radius is on the horizontal and the volume depends on the radius. So we'll start at 0 0, then we've got 1 3, 4 12, 9 27, etc., and it'll make a nice curve, hopefully. Part E says find the volume of the pool when the radius is 2.5 and 3.8. Using the graph that you created on graph paper, you can find 2.5 on the graph and go up to the volume and across. The same with 3.8, will be just a bit further up. And you can do the same for question F, which says find the radius, but this time you're going to go to the volume on the vertical and down to the horizontal to find the radius that matches that volume.